Welcome to our SQL series, where we'll explore 10 essential queries every beginner should know. Whether you're into data analytics, engineering, software development, or business intelligence, these simple examples are designed to get you started right away. Let's dive in and build a solid foundation together. Today, we're diving into some essential tools for working with data in databases. We'll start with Select, the foundation for pulling data from tables. Then, we'll filter that data with WHERE, sort it using order by, and remove duplicates with distinct. We'll count records, group data by categories, and calculate totals and averages. We'll also combine tables with join, match multiple values with IN, limit results with limit, and use like to find text patterns. This overview sets the stage for everything we'll explore. When we write SQL queries, it's tempting to use the asterisk to grab all columns. It's quick and easy. But in production, we want to be more precise. Selecting specific columns, like employee name and salary, helps the database work faster and keeps our results clear. This slide shows how choosing columns by name, rather than using the wildcard, improves performance and makes our queries more efficient. It's a small change that pays off big. The where clause is how we filter records in a database. It lets us specify conditions that rows must meet to be included in the results. For example, we can select employees with a salary greater than $50,000 or filter by department, like only those in it. Operators like equals, greater than, less than, and logical connectors like and, or, and not help us build these conditions. It's a powerful way to narrow down data exactly how we need it. When we want to organize our data, the order by clause is our go-to tool. We can sort results by one or more columns, for example, ordering by department in ascending order, then salary in descending order. This lets us see, say, the lowest salaries first, or flip it around to see the highest. It's especially handy for reports and dashboards, where clear, sorted data makes all the difference. Let's explore how order by shapes our query results. When we use distinct in a query, it applies to all the columns we've selected, not just one. For example, if we select distinct job titles, we get a list of unique job titles in the data. The same goes for departments. Distinct filters out duplicates, showing only unique entries. This is really useful when we want to explore the different categories or groups in our data, without any repeats cluttering the results. It's a simple way to focus on what's truly unique. Let's talk about the count function, a simple but powerful tool for counting rows in a database. When you use count with an asterisk, it counts every row, no exceptions. But if you count a specific column, it skips any rows where that column is null. For example, to find how many employees work in IT, you'd count all rows where the department is it. Or just count all employees with count star. It's a go-to for quick summaries and reports. When we want to summarize data by category, we use group by. It groups rows that share the same value in a column, like department, for example. Then, we can apply aggregate functions like count or sum to each group. But what if we want to filter these groups based on the aggregated results? That's where HAVING comes in. It works like WHERE, but for groups instead of individual rows. This lets us focus on groups that meet specific criteria after aggregation. Let's talk about two key aggregate functions, sum and AVG. These are essential when we want to do numerical calculations, like finding totals or averages. For example, sum adds up all the salaries in a company, giving you the total amount paid. AVG, on the other hand, calculates the average salary. Both ignore null values automatically, so they only consider actual numbers. These functions are vital for financial reports and analytical queries, helping us make sense of the data quickly. Let's talk about the different types of joins in SQL: inner, left, right, and full outer. The inner join is the default, and it connects rows from two tables where the keys match. In this example, we join employees with their departments using a shared department ID. Joins are powerful because they let us combine related data from multiple tables, making complex queries possible and meaningful. This is how we bring separate pieces of information together into one clear result. Let's talk about the IN operator and why it's so handy. Instead of writing multiple OR conditions, which can get long and messy, it lets us check if a value matches any item in a list, simple and clean. For example, Instead of saying department equals IT or department equals HR, we just say department in IT and HR. It's easier to read, easier to write, and works great with subqueries too. A neat way to keep your queries tidy. When working with databases, controlling how many rows you get back is key, especially with large datasets. In SQL Server, you use top to grab a set number of rows. Oracle uses fetch first with a similar effect. Then there's limit, common in other systems, which lets you specify exactly how many rows to return. You can even skip rows using offset. This is perfect for paging through results or just narrowing down your data quickly. It's all about getting just what you need, no more, no less. Let's talk about the like operator, a powerful tool for searching text patterns in databases. When you want to find names or words that match a certain pattern, like is your go-to. The %sign stands for any sequence of characters, while the underscore matches exactly one character. For example, searching for %sun finds any name containing sun anywhere. Or A% finds names starting with the letter A. It's simple, flexible, and essential for text searches. Let's wrap up with a quick recap of 10 essential queries you'll want to master. We start with retrieving data using select, then filtering rows with WHERE, and sorting results through order by. Next, we find unique values with distinct and count records using count. Summarizing data happens with group by, while calculating aggregates like sum and AVG helps with totals and averages. Joining tables combines information, matching lists with IN, and finally, limiting rows with limit keeps results manageable. These are the building blocks for powerful data searches. Thanks for joining me today. If you found this helpful, don't forget to like, subscribe, and drop a comment with the next SQL topic you want to explore. Mastering these 10 queries sets you up to query smarter, whether you're into software development, business intelligence, or data analytics. See you next time. This video was created with SlideSpeak. Visit SlideSpeak to turn your presentations into engaging AI-narrated videos.